Hello, welcome to today's class. So today's class will be on binary subtraction. Uh, so here is the truth table for binary subtraction, where we are subtracting one bit from another. We name the bits x and y, so we are performing x minus y. So the two inputs are x and y, and we are trying to compute x minus y. So when we try to perform subtraction of two bits, we will actually generate two outputs. The first output is called borrow, and the second output is called the difference. All the rows in this truth table should be obvious except for the second row. So let me we'll look at this row in detail, but if we look at the other three rows, in case of the first row, the value of x is 0 and the value of y is 0. So we are trying to compute 0 minus 0, and hence the difference will be 0, and we don't need any borrow, so borrow will also be 0. For the third row, where the value of x is 1 and the value of y is 0, we are now trying to do the subtraction 1 minus 0, and 1 minus 0 will result in a difference of 1. Again, we don't need to borrow, so the borrow output will be 0. For the last row, the value of x is 1, the value of y is 1, so we are trying to compute 1 minus 1, and 1 minus 1 will result in a difference of 0, and again we don't need to borrow, so the b output will also be 0. But in case of the second row, which I have marked here, we are trying to do the subtraction 0 minus 1. So we are subtracting a larger number from a smaller number. So how this subtraction will be done, let us try to understand how actually we perform similar subtraction in decimal number system. So here I take the example 73 minus 26, and to perform this subtraction we first have to subtract 6 from 3 in the first stage, and as we try to subtract 6 from 3, we see that we are trying to subtract a larger number from a smaller number. Hence we will need to borrow from the previous stage, and when we borrow from the previous stage, 3 will get replaced by 13 and 7 will get replaced by 6, and now we can perform the subtraction, and 13 minus 6 will result in 7, and 6 minus 2 will result in 4. So this is how we do subtraction in decimal number system, and whenever we subtract a larger number from a smaller number, we will need to borrow, and when we borrow, we saw that 3 gets replaced by 13 and 7 gets replaced by 7 minus 1, which is 6. Now this particular row where we are trying to compute 0 minus 1, so we are trying to subtract a larger number 1 from a smaller number, which is 0, and hence we will need to borrow. Whenever we subtract a larger number from a smaller number, we will need to borrow, and that's why this b output is 1. Now when we borrow, as we saw in case of decimal number system, 3 got replaced by 13. Similarly, this 0 will get replaced by 10. In decimal number system, in the example we saw that 3 got replaced by 13, 1 3. Now in case of binary number system, when we borrow, this 0 will be replaced by 1 0. So now the subtraction becomes 1 0 minus 1. 1 0 is 2, so 2 minus 1 will result in a difference of 1. So the when we perform the subtraction 1 0 minus 1, the difference will be 1. So that explains why the output for this row is 1 1. So here is the truth table for binary subtraction, and the logic circuit that implements this truth table is called the half subtractor. In the lab class today, we will try to implement the logic circuit for this truth table. And now, just like in case of binary addition, we have half adder and full adder. Similarly, in binary subtraction, we have a half subtractor and a full subtractor. We will look at the full subtractor in the next class. So this is all I have for today. We'll meet in the next class again, and we'll discuss about full subtractor. I like to stop here for today. Thank you. Bye.